Hi everyone, I'm Roberto Garcia and I'm here at the Analytical Instrumentation Facility, and more specifically I'm in the FIB lab. Today what I want to do is I want to show you how to do a FIB lift out of a silicon sample, and we're actually going to thin down the silicon in the final thinnings process in two different ways, because I know people do it differently. I just want to let you know that there's more than one way to actually get a good finished sample. The other thing I'm going to do is I'm going to go very detailed into the process, and I'm going to answer a lot of questions as far as why we're doing certain things. Because a lot of times I get students asking me, why are we doing something in particular? So I'm going to go ahead and delve into that. The other thing I'll do is I'll put kind of like the headings in here, the titles, and split this video up a little bit so that if you already know, or you're kind of an intermediate user and you kind of know all these things, you can kind of jump ahead to where you want to be at. Okay, so let's get started. I'm already pumped down. I've got my sample in. I'm going to go ahead and start. You'll notice that my electron beam, the beam is on. It's a field emission source, so it's always going to be on. It's just that there's a gate valve, so it's not open to the chamber. So that's why I was able to pump down the chamber. The ion beam, on the other hand, that one is not on. You see that there's no green light up here. And the reason is that we have a finite amount of gallon. So what I want to do is I want to wake up the system. And what that's going to do is it's basically going to warm up the gallium and start the flow and get some emissions. And once I get that emissions, this will go green. But while we're doing that, I'm going to go ahead and set my Eucentric position, because that'll take some time to warm up the ion beam. So I'm going to go ahead and unpause here. Let's go back to live. I'm going to go and set my conditions first. I know I'm going to deposit platinum with 2 kV, so I'm going to go ahead and change this to 2 kV in the electron beam, and I'm going to be in the analytical mode, so that's going to give me higher currents. Okay, so I'm going to give myself a little bit more rabbit, and then let's see, we're going to do this at 8 nanoamps. And the one thing I want to do is I want to adjust my contrast and brightness, and what I'm telling people now is just push F9, which is the automatic contrast and brightness, and that's going to give you a very quick adjustment. So it actually works out pretty well. I'm going to hit Control 0 to center the stage, and now I know that my sample is off to the left over here. Okay, so I've got 2 samples here. I'll just start off on this top one. I'm going to hit F5 to get the full screen. So the first thing we have to do is we have to link the stage. So if I go over to the stage page here, you can see that I've got this red arrow here indicating that there's really, basically the system doesn't know how tall my sample is. So I'm going to let it know. So I'm going to zoom in to about, let's say 500 or 1000 magnification. I'm going to do a quick focus on the surface. And as I'm focusing, you can see that my working distance is changing. So right now what I'm going to do is I'm going to focus. And my working distance is 25.4. And you can still see the Z is a little bit off. So now I'm just going to push the link the stage button. And now it's transferred that parameter over to the instrument. So now the instrument knows that the top surface of my sample is 25.4 millimeters away from the top. So now the next things I want to do is I want to go ahead and I want to move it closer. So we're going to go up to 15 millimeters first. Hit enter. And the same thing, I'm going to zoom up. I'm going to do a focus. And then I'm going to go ahead and link the stage again. And then I'm going to go up to 10. And you can see that distance changed a little bit. So now we're going to go up to 10. Let's see, I want to find a feature of interest, something that I can easily identify. And we're going to do this at 2,500. I'm going to go ahead and focus. As good a focus as I can. And now what I'm going to do is I'm going to link the stage again. It's a little bit off. I'm going to set it back to 10. And now I'm going to do a center this little spot again. And I'm going to do a series of tilts. So I'm going to tilt to 15 first. I'm going to see how that little feature moves. Okay, so it moved down quite a bit. So now I'm going over to the front of the instrument and I'm adjusting the Z knob manually to bring that same feature right back up to that crosshair in the center. So it's right there. Okay. Now I'm going to go back to 0 tilt, which is Control E on the keyboard. I'm going to go ahead and refocus. I'm going to center that again, and I'm going to relink the stage, and you'll see that it's changed a little bit. Okay. So now, next thing, I'm going to go up to 30. Moved a little bit, so I'm going to adjust that back. And overall, it didn't move a lot, so I'm just going to go straight up to 52 degrees. So that's Control I on the keyboard. Okay, so everything's pretty much still. So everything's okay. So I'm going to go to Control E. Now, the one thing I forgot to do is what we should do when we first start is to go ahead and warm up the platinum. So I'm going to double click to warm that up. In the meantime, I'm now going to find an area where I want to deposit my platinum. Okay, so this is an old sample that I've used. So I'm going to go to just try and find as clean a spot as I can. All right, and that looks pretty good. So next thing I'm going to do is I'm going to go ahead and I can draw out a rectangle. I'm going to put it in serial mode and then change the application to what I want, which is Platinum Optimize or Platinum 5 kV, 8 nanoamps. I know it says 5 kV, but 2 kV actually works better. And I can go ahead and change my parameters here. Now, the other thing I can do is I can just go to File, Import Patterns, and we already have some patterns set up here. So I could go to Platinum EDEP, and everything's already set up. So I already have, if I check this, you can see I have the right application file, the size that I want, and the Z height that I want. Basically, it's going to tell me, it's telling me that it's going to take about 3 minutes. I've made these preset patterns ahead of time to make it a little bit easier. Now, why are we depositing with the electron beam? The issue is that if we go to the ion beam, there's going to be a little bit of a lag between when we actually start the ion beam and we actually start to get deposition. So if you're interested in nano layers on the surface of silicon or just material in general, you want to make sure that whatever area you're looking at that you're interested in, that you have that protected. Okay, so that as soon as we turn on the ion beam, it's not going to damage anything underneath where you want to look at. So this is just a precaution. The other option is we could have coated it with gold palladium or put on another coating beforehand, but this is just as quick. It's only going to take 3 minutes. It would take you probably that long, if not longer, to do that in the sputter coater. So it's taken a while, so that tells me this is probably the first time that the platinum has been used today. So now it's warm. So what I'm going to do is I'm going to zoom out so that you can see on the infrared camera here that I'm going to insert my platinum needle. And it's going to come right up very close to the surface of my sample. So this one is actually positioned, I think, 600 microns above the sample. So if I want to, I can take a look at that. I'm just going to go ahead and zoom out, and you can see how close that needle is and how relatively large that needle is in comparison to where we're going to be depositing. So I'm just going to go back up. The one thing I want to do, again, before I start depositing, is I want to double click where it says closed so that I can actually open up the flow. And what I'm looking for is down here at the chamber pressure. So when I double click on the closed, I should see this pressure come up, and that's telling me that I at least have some flow going into the chamber. So let's double click there, and I'm going to look at that chamber pressure. And it's starting to go up a little bit. Again, like I said, it looks like we probably were the first ones using the platinum today. That's why it's going up very slowly. Let me adjust the contrast again. So as the electron beam is going, I am actually depositing platinum over this area, but I don't particularly care because a lot of this area is going to be damaged in the removal anyway. So once I've got a good flow going and my chamber pressure is increased, I'm just going to go ahead and hit start. And then it's just going to go over this entire area here. Now, one thing that you're going to see is, you may notice this on your sample, is you may get some drift with the electron beam. We're using a fairly high current, and you're going to see some drift going on. If you see that, you need to adjust with your X and Y shifts. Okay, so I'm using my shifts now to kind of shift the beam around. So you want to maintain it in one particular area so you get your deposition in one area. If it drifts a little bit, it's not that big of a deal. We're going to deposit 250 nanometers of platinum. So it's probably overkill. We probably only need like 100 nanometers. But again, like I said, we want to make sure we don't damage your sample. And now, one thing I didn't mention is the eucentric position. A lot of people ask, well, why do we have to be at the eucentric position? Okay, there's a couple of reasons. One, the eucentric position is where all the needles are calibrated to. So if I'm at my eucentric and I stick in my deposition needle or my lift-out needle, I know that they're going to be a certain distance above that sample, and I'm going to get consistent deposition rates. If I'm not at that position, one, if I'm too close, I can actually crash into it, which would cause a lot of damage to your sample, also to the needle, and then we might suffer some downtime. If I'm too far away, I may not get the required amount that I want as far as my deposition. So all these depositions are set for this particular distance. The other thing that you'll see when we actually start to do our removal is that the eucentric position is one point where we can actually do work with the ion beam and observe that work with the electron beam at the same time. So if they're not at that eucentric position, you can remove material, you can do depositions, but what will end up happening is you won't be able to really see what's happening as you're going. So that's a big plus, to be able to see that, because you never know. Like right now, I'm actually able to adjust and make sure that I'm depositing in the right area. If I wasn't able to do that, who knows what would happen with this deposition. It might drift off quite a ways. and I've been adjusting. You can see that it's kind of just moving around a little bit. A little bit of motion is okay. Major is bad. So we're done there. So now I'm going to delete my pattern, and I'm going to observe my deposition. Okay, so we got a good deposition. Doesn't show any drift. I'm okay running the electron beam. I know a lot of people, when they first start, I always warn them about the ion beam damaging their sample. Well, the electron beam is not going to damage your sample, so don't ever worry about trying to damage your sample with the electron beam. So everything's okay. I do want to show you the safety feature. So the next thing I need to do is I have to deposit with the ion beam, so I need to tilt up to 52. Well, you can see here, my tilt is actually, tilt and rotation are grayed out. Well, I haven't removed my needle yet. Okay, so it knows, the instrument is aware that the needle's in there, and it's not gonna let you tilt until you remove that needle. So I'm gonna go ahead and remove that needle. I'm gonna readjust my contrast and brightness. Okay, and now if I go over there, you can see that now my tilt and rotation are freed up. So now I'm just going to go to 52 degrees, so I'm going to hit Control I. It's just my contrast and brightness again. I'm just a little bit off on my Z, so I'm going to bring that up just a little bit. Okay. Actually, so the next thing to do is to get my ion beam all set. So I'm going to pause here. I'm going to go to the ion beam. I'm going to the main page. Okay, so now my ion beam is all warmed up. I've got everything going on. Everything's great. The beam is not on. Okay, so this happens a lot of times. Sometimes the beam on button comes on when you hit the wake up. Sometimes it doesn't. So what I'm going to do is I'm going to have to turn that on. But first, I'm going to set up my conditions. I'm going to be at 30 kV. And I want to be at what's considered a imaging current. So typically, like I said, you don't want to damage your sample. We have protected the area underneath, so we don't have to worry about damaging this area that we want to look at. But I don't want to hit it with a very heavy beam, because then it'll kind of remove that protection very quickly. So you want a light current. So typically anywhere between 30, 49, some people even use 10. I like to use 49 because most people use the 30, and I'll try to use this other aperture. I'm going to go ahead and turn the beam on. And since we are at Eucentric, it should be fairly close. So now I'm going to go ahead and turn on my beam, and I am. Okay, so I'm really spot on. All right. So the next thing to do is to do a deposition. I'm going to File, Import, Patterns, and I want the platinum deposition. And I can move that over. Let's go ahead and hit F5. Now what it's telling me here is it's going to take 33 minutes. That's because it's based on this current that we have up here, which is 49. I want to do this at 0.5 nanoamps. But before I do this, I need to focus the 0.5 nanoamp beam. So this is something I tell a lot of people. If I've got silicon, I don't have a lot of features, and supposedly your sample shouldn't be as dirty as mine is, but you shouldn't have all these little pieces of dust and everything on the surface. So what I want to do is I want to go to Scan and do Spot mode. So I'm going to take this spot. I'm just going to put it right here in this lower left-hand corner. And this little thing right up here, this is my beam blanker. I'm going to go ahead and turn that off, or basically that could be Control B is the shortcut. And I'm going to do that for 10 Mississippis, or 10 seconds. Okay, then I'm going to blank it again. I'm going to go back to Scan and Full Frame. And then I'm going to go to the reduced area, or F7. And I'm going to bring this down. I'm going to bring this over to that area and then unpause. Okay, so now I've drilled this little hole, a little feature on the surface that I can now use to focus on. All right. whereas I wouldn't have anything before. I've got stuff on the surface, you can see, but it's milling away very quickly. So having this little hole in the surface actually helps out quite a bit. So now that that's done, I'll get rid of that and I'll take a snapshot. Okay, so now everything looks pretty good. I'm gonna bring my platinum here. So my deposition is going to be 12. I'm going to make this a little bit longer today because I want to get 2 sections out of here. So let's do 15. Normally I would just do 12. And then, yeah, everything looks pretty good. So I'm now going to put in the platinum needle. And so this is something that I always tell students too. Before you actually start any deposition, take a snapshot. Okay, so this is my image, what it looked like before I put the platinum needle in. I'm gonna take another snapshot. Notice that it moved just slightly. So you always wanna make sure that just before you start your deposition, you take a snapshot to make sure that any drift or anything is accounted for. Okay, so I've got my sample set up there. Again, I'm going to double click where it says closed to get the flow going, and I'm going to look at my chamber pressure. I want it to be up into the -5 or at least see that it's increasing. Okay, so it's increasing. So I'm going to go ahead and start. So I'm going to pattern. It's going to take 4 minutes. Same thing here. I want to take a quick look here. I don't think I'm getting any drift, which is good. But it's always nice if you see that this is too bright, bring your contrast down a little bit so you can kind of make out where you're at. And what you want to do is just make sure that it's not drifting. And if it is, again, use the X and Y shifts to correct for that. Okay, it's done. So now I'm just gonna check it very quick with the electron beam. You can see I got a really good deposition there. That's what I want to see. So I'm gonna come over here. I'm gonna delete that pattern. I'm gonna retract my needle. So I don't really need the high currents anymore. So I'm gonna go ahead and go back to what I like to view my sample at, and that's at 5 kV and in standard condition. Okay, and then 5 kV and 53 picoamps is what I prefer to use. And again, I'll hit F9 for the automatic brightness and contrast. And I'm just gonna go ahead and focus this a little bit. So the next step is to go ahead and do our initial Hog-Out. Okay. So at this point, again, I can go to File, Import, Patterns, Silicon 30 kV 7 nanoamp Hog-Out. I'm going to go ahead and open. Now these are actually 4 patterns, and you can see that it's cleaning cross section. So there's 4 patterns there, and they're already preset. You can go ahead and do that. You can see that the front one is just a little bit. I'm going to take a snapshot again and bring this down a little bit so you can see this better. You can see that the front one is a little bit shorter than the back one. In this position, our ion beam is coming from the top down. Okay, so it's actually located on the top side of this. So when we do our J-cut, we need to have enough clearance for it to get down to the bottom. So that's why the back side is usually a little bit larger than the front side. The other thing we have to do now too is we have to set everything up at 7 nanoamps. I'm gonna go back to 7 nanoamps. And I'm going to hide my patterns so I don't see them. I'm going to go back to my little area here that's got the little defect on there, and I'm going to unpause. And again, I'm going to use that area to focus and stigmate. A lot of stigmation. And again, I really don't care about this area, so it's okay that I'm blowing everything else away. So same thing, I'm going to go ahead and stop. Then I'm going to take a quick snapshot. Okay. So unhide again. And now what I need to do is I have to hit Control A so that I grab all the patterns. And I'm just going to straddle this right over the center of those patterns. Now you have to have the patterns in full view. If for some reason I'm up at a higher magnification and the patterns are being cut off, you're going to get a warning saying that it's not going to start because the pattern's not in the field of view. So we're going to come all the way down, take another snapshot. Okay, everything looks good. And this is so 14 minutes. I basically have the pattern set up. It should be pre-done. Everything is all set. We're just going to hit start, and in 14 minutes we'll be done. And if I want to, I can hit F5 and watch the progress over here by hitting F4 every now and then. Okay, and that's primarily why you have the eucentric position and why you want to set up in the eucentric position, to make sure. So I can check here that I don't drift too close to the sample and actually start removing some of that platinum that I want. The next step, which is kind of a cleanup cut. So I'm going to get closer and closer to the platinum deposition without destroying it. So I'm going to need a smaller beam. So I'm going to come over here, Control A, delete all my patterns. And then I'm going to go to 3 nanoamps. I'm going to finish up with 3 nanoamps. I'm also going to tilt my sample in a positive direction. So I'm going to go 56 degrees. So plus 4 degrees. I'm going to pause here, and I'm going to come over here, hit F7 and unpause. And why am I going 4 degrees? One of the things that happens is that as we're milling straight down, we actually are not getting a very parallel side. It's actually getting kind of tapered at the bottom. And I can show you an image that will show you the exact issue that's going on. As we go down here, we're actually getting a very wide bottom. So we're going to have to actually cut that off with our J-cut later. So what I want to do is try and get that as parallel or even thinner at the bottom as possible. I'm going to take my snapshot and I'm going to adjust my contrast a little bit just so I can see this a little bit better. So what I'm going to do now is I'm going to come in with a clean cross section again, and I'm going to come in, and this is going to be silicon, very high current. We're only going to do a Z of 1. And let's see, I'm at 20, let's make this 25 like we had before. Gives us plenty of room to cut. And now typically I don't go all the way to 25. I will actually do 20 at this point. Remember, our platinum deposition is just 15, but like I said, I'm gonna be doing 2 basically windows in this one. So I wanna give myself plenty of room. So I don't have to go all the way to the back here, okay? So if I try to do that, it's gonna take 10 minutes. I've already hogged out that area. What I wanna do is I wanna remove this kind of slanted material here and get really close to my platinum. So I'm gonna take a snapshot of this again. I'll zoom up a little bit to really show you what I'm doing. So now that I've tilted, this bright area that you're seeing here is just an area that is very steep with respect to the beam. So that's basically like the sidewall of this window that we're going to create. So what I'm going to do is, just like I did before, I'm going to run this twice. So we're going to run it once, and then I'm just going to hit it and run it again. And all I'm looking to do now is, 1, thin this further so that I can get very close to that platinum cap so I don't have to remove a lot of material with the J-cut, but also try and get those sides very parallel. Okay, let's take a snapshot. Okay, see, I've gone right up to the platinum. Let me take another snapshot here with the ion beam. Okay, so I've cut it down a little bit thinner, and I'm just going to run this again just to make sure that I've got parallel sides. So like I said before, it usually takes about 2 tries. That's why I usually, with the cleaning cross section, to get it nice and parallel. Okay, so now that that's done, I'm going to now go to the other side. So that means I'm going to tilt -4 degrees from 52. So that's going to set up 48. And what I want to do now is I want to take this pattern and I'm going to go, instead of bottom to top, top to bottom. Okay, take a snapshot. Just like before, you can see that I have this bright area. That's the region that's kind of slanted with respect to the beam. And a slight tilt, so I'm going to bring this all the way back. It's probably going to drift a little bit because I just tilted it, but it's going to take 4 minutes, so I'm just going to do the same thing. Just going to go ahead and start, and I'm going to run that twice. Okay, now that everything's thinned out, take a quick look here. Everything looks good. I'm going to go ahead and delete my pattern here. And now we're going to do the J-cut. You can see that the sample here is roughly 2 microns thick. So now we're going to go to 0 tilt. So Control E. And here's something I always warn people about. You can always double click to get everything to the center in whatever beam you're perpendicular to, okay? Because we're not at an angle. So it's basically an X and Y shift. So I can double click and get that to the center. I don't want to do that in the ion beam because now I'm inclined in that area. So what I'm going to do here is I'm going to take a quick snapshot. And my sample is a little bit off, so I can't really set up for my J-cut. So what I'm going to do is I'm going to manually go to the front of the instrument and use the Z knob, and I'm going to go counterclockwise a little bit. Take a snapshot, and I'm in field of view, so now I can go ahead and do my J-cut. All right. So now, just like before, I've saved import patterns. J-cut, and you can see it's at 30 kV, 3 nanoamps. And what I'm going to do is I'm just going to go ahead and position this. Control A. Let's go to my patterning page. Control A, and I'm going to go ahead and position this. So notice that I've got this bar coming way up here to make sure that I've cut off this end here. I'm going to extend this a little bit, so I'm going to go to undo that. I'm going to bring this out a little bit further here, and I'm going to bring this over to this end over here. And you can see I've got 2 patterns here, so that I'm going over the bottom twice. And the reason for that is I want to make sure that I'm cut away at the bottom. Remember, all of my information is up at the top here, so I really don't care. I've got plenty of material here. I've got plenty of room, so not to worry. It doesn't matter here the Z size, because like I said, I'm going to be monitoring this to check to see when I've gone through. So once that's set, I'm going to take a snapshot, make sure nothing's drifted a little bit. Like Control A and readjust that a little. Okay, and then I'm just going to go ahead and start. And then I can adjust my contrast here, and that's going to allow me to see exactly when I punch through on the front side, on this back side here. I'm also going to go to monitor over here on this side. I'm going to hit F4 every now and then just to make sure. I want to make sure that I can see that inverted J right on this front side here. Here, so you can see I'm starting to punch through on the corners here. So if I come over here and take a snapshot, I should start to see something transferred on the front side there. So see at the bottom here, I'm seeing a little bit of removal. Okay, so now it's cut away on the left-hand side, so I can go ahead and stop. Okay. So what I want to see here very clearly is that I've got this inverted J cut into the front here. All right, so that lets me know that this sample is cut away completely. Okay, that's good. Okay, so now the other thing is, if you, for some reason, you think that it might still be attached, what I recommend to most people is to go ahead and tilt up a little bit. Let's go ahead and tilt up to about 30 degrees. Again, with the electron beam, just to be absolutely sure. And you might have to adjust your Z. Remember, we went counterclockwise. And now At around 30 degrees, anywhere between 30 to 45 degrees, you can clearly see that you've cut away the material. Okay, so if for some reason there's just a little bit of doubt in your mind, just go up to 30 degrees and just check that out. Okay, so I'm gonna go back to 0. And then the next thing to do is to go ahead and do my lift out. So I'm going to come over to my patterns here, Control A, delete them all. And the first thing I'm going to do is I'm going to go counterclockwise about a half a turn with the xenon. Okay, so I'm going to use my fingers to go ahead and measure. I'm going to go half a turn counterclockwise. Right, and that's going to move my sample far enough away so that I know I'm not going to hit it with the Omniprobe. So the first thing I'm going to do is I'm going to insert my platinum needle. I'm going to go to the Omniprobe program. I'm going to check to make sure it's in the park position. Okay, so the last person should have taken it out at the park position, but just in case they forgot, if for some reason I try to put it in at the 0.1 position, it may actually hit my sample and knock it out. So it's in the park position. I'm going to go ahead and insert the Omniprobe. Okay, it's in there as well, and what I'll do is I'll zoom out so you can see both of them. All right, so it's far enough away, it's in the park position. I'm going to go to the Eucentric position, but in this case, it's called 0.1 on the program. So I'm going to move it to that 0.1 position, and it's going to be very close to our Eucentric. The other thing I'm going to do also is I'm going to be viewing the sample a little bit. So I'm going to go back to my imaging current. And my needle looks a little bit funky. So I'm going to go ahead and take a look at it with the ion beam. And yeah, it looks really funky. So what I'm going to do is I'm going to sharpen that up a little bit. I'll move it down a little bit further. And what I want to do is just trim it up a little bit just to make sure it's okay. So what I'm going to do is I'm going to jump up to about 7 nanoamps. And I go to the metal application file. I'm going to remove about, let's set it to 4 microns or so. I'm going to rotate this around. I want this to be kind of in line with the sample, with the needle. And then I'm going to copy this again and move this to this side, and I'm going to kind of make it a little bit sharper. All right, and then I'm going to do this in parallel. I'm just going to let it go. Actually, stop, take a snapshot. I forgot to image it. 7 nanoamps. There we go. So I'm going to put this over here. There. Just want to get this a little bit tighter. And you may have to do this. Sometimes people leave too much platinum on the end of the needle. It looks here like someone cut off way more of the tungsten than they were supposed to. Delete that. I'll go back to my imaging current. Okay. Now I'm going to come over here and I'm going to position my needle right over, and this time I'm using the software controls. I'm going to position that needle right over to the left-hand side of my sample. okay, to that little, right there. Pause. Go to the ion beam, start that up. Okay, so I'm right in the center there, so that's good. Now I'm going to start to raise up the sample with the Z knob manually. So I'm going to bring this up. And then right before I'm going to touch, I'm going to pause. I'm going to come over here to the electron beam again and make sure I'm lined up. So you can see that it moved off a little bit. So I'm just going to go ahead and move that up a little bit more. So it's going to touch right at the top. So now I'm going to zoom in a little bit more. And as soon as I touch, you'll probably see a change in contrast or some horizontal lines. So right there. So that's where I know that I've touched the sample. So I'm going to pause. And the first thing I want to do is I'm going to basically attach the needle. So I'm going to do a rectangular section, platinum optimized for 1 nanoamp. I'm only going to do a deposition of 1 micron. Now I'm going to use 0.5 nanoamps for the deposition. And I'm going to come and focus the beam right on my needle. Okay, I want to get a nice focus with the beam. Okay. Take a snapshot. Okay, and what I want is I want to aim for about a 1-minute deposition, and I want to make sure that I'm hitting my window and also getting over the needle, because that's going to be my attachment. And if I need to, I'm going to extend this out. So 50 seconds, not too bad. Double click to open up the flow. And then again, I'm going to look at my chamber pressure. It's 5.27 to the -6. It's climbing, so I know I'm getting some flow. So now that I've done that, I'm going to go ahead and start this up. And after this starts, I'm going to bring down my contrast. Okay. This happens every now and then, but a lot of times the image will shift a little bit, or the pattern shifts. So again, you use your X and Y shifts to make sure that it's in the right position. Okay, and once that's done, I'm gonna hide my pattern, take a snapshot, make sure I got a good deposition, it's attached. I can even see over here with this one, make sure that I've got a deposition on the surface, it's attached. So now what I'm gonna do is I'm gonna come back to my ion beam, unhide my sample or the pattern, get rid of it. And what I'm gonna do is I'm just gonna cut away using the reduced area. Okay, so all I have to do is unpause there, and you can see I can just put it right where I want it. I can bring this down, make it as small as possible, cut it faster. So all I need to do is just get rid of that little area right there that's holding on to the sample. Yep, and then once that's cut, I'm gonna pause there. Go over to my electron beam. I can see that it's cut. You can see that it's kind of wiggling because the sample now is cut away from the substrate and it's just hitting the needle. So now I'm gonna go Z counterclockwise manually and just kind of bring it down a couple of turns, okay? So now the next thing to do is I'm going to bring my needle to the eucentric high. So basically it's going to be in the same position, but it's actually going to be high above, almost above the needle, so that I don't bump it with anything. Come over here and get rid of my reduced area. And I'm gonna drop down in magnification. So now what you're gonna do, I'm gonna leave my needle and everything in because my sample, if you look at it here, my sample is a lot higher than where my grids are gonna be. So what I'm gonna do is I'm just gonna move over, and I can use the arrow keys. I'm gonna move to the right, and my grid's right there. The area that I want is this little prong right here. And you can see it's not exactly parallel, not exactly horizontal. So since I have my needles in, I can't use anything automatic to line it up. So what I'm gonna do is I'm just gonna take the rotation knob and make sure that it's nice and horizontal. Okay, just a little bit touch up there. And now I'm gonna go pause here, go to the ion beam, unpause, let's adjust the contrast. I'm fairly far out as magnification and you can't see the sample, and that's because, again, I've lifted it up above the needle. Now I'm taking the Z knob and I'm going clockwise, and I'm going fairly fast because, like I said, I'm very far away. And I kind of know what I'm getting. So see that little kind of like curvature here? That's that little well where these grids are held in. So the grid should start to pop up fairly soon. There it is. Okay. I'm gonna move it over with the X a little bit. Okay, so the first thing I wanna do, and this is a couple of steps, it's just gonna take a couple of minutes, is I want to clean off the surface of the grid. You can see there's a lot of junk on there, right? So what I want to do is I want to hop up to about 50 nanoamps. Okay, and all I'm doing now is just burning off any hydrocarbons that are on the surface, anything that's going to basically not make my sample want to stick to the surface. So I'm just gonna go ahead and just kind of burn this off a little bit. Any of that dark stuff, you're gonna see it get a little bit brighter. I just wanna make sure I don't have any contamination on the surface. The other thing too is you don't want any contamination, so that when you go to the TEM, once you hit it, you're gonna get those hydrocarbons come out and deposit onto your sample. Everything looks pretty clean here. I'm gonna pause here, get rid of the reduced area, and I'm gonna make a notch. Again, you don't have to do this. A lot of people do deposit on this little V notch here without making a notch. Some people deposit flag style. I've always made this notch. I've never had any issues with the sample falling off, so that's what I tell people. So my distance is gonna be 25 microns for the X. The Z, I'm gonna make something like 10. Let's go up. Again, I'm at 50 nanoamps. And I'm just gonna put this on here, right there. All I need is just a very small amount just to kind of land it. I'm just gonna let it run. Increase my contrast so I can see when I'm done. Okay, everything looks like it's cut away. I'm just gonna go and check the electron beam. Contrast down, check again. Okay, and that's that small notch that I created. And everything looks nice, it's all flat, so I'm gonna come over here and I'm gonna stop. First thing I wanna do is go back to my imaging current to make sure that I don't burn away my sample as I put it in. And delete that pattern. Unpause, hit F9 to adjust the contrast. And I wanna make sure, a couple of things here. One, I'm going to make sure that it's in the center, so I'm gonna double click to get that slot into the center. And I also wanna make sure that it's far enough away that if I insert my sample, I'm not gonna hit it. And that's far enough away. You kind of want it at the edge of the image there. So I'm just gonna go ahead and go back to point 1, which is my Eucentric position. pause here. The electron beam. Okay, and I'm going to adjust that up. I want to put it right in the center of that slot. A little bit to the one side. And then I'm going to come over here to the ion beam. I'm going to focus on my sample, and then I'm going to slowly raise up the grid. Okay. And just like before, just before I touch, I'm going to check my alignment again. Okay, it shifted a little bit, not a lot, but I'm going to just shift it back a little. Okay. And then I'm going to come in and I'm going to touch, and again, you're going to see a bunch. You'll either see a change in contrast or you're going to see a bunch of horizontal lines. There we go, changing contrast. All right. So now I got to glue it into place. So what I'm going to do is I'm going to deposit some platinum on the right-hand side. Platinum optimized 1. That's going 2 microns. And then I'm going to deposit a circle. And now the thing is, when you're doing this, you want to be in serial mode. If you try and deposit 2 different areas at different sizes, this does some very weird things to each one. So you want to be in serial mode. I'm going to deposit a circle. The circle is just going to be 5 microns, and I'm going to put it right on the corner of where that sample is. And then I'm going to do this in parallel. And now it says it's going to take about an hour. Again, we're going to do this not at 49 picoamps, but at 1 nanoamp. So now I'm going to focus and stigmate up here on my grid. Everything looks good. Take a snapshot. I'm going to go ahead and make my adjustments. Oops. Let's move that over. Same thing here. It doesn't have to be this tall. Again, we're just kind of gluing it in place. 3 minutes. So now all I have to do is open up the flow, make sure my chamber pressure goes up. Okay, and then run it. And just like before, I'm going to decrease my contrast. And you see it kind of moved off a little bit. So I want to bring it back with my Y shift. It's usually always in the Y direction, so I'm going to bring it back with my Y shift and let it go ahead and deposit. All right, that's done. We'll hide the patterns, take a snapshot. Looks like it's attached pretty well. I'm gonna take also a look over here. And that looks pretty good. Looks good. All right, so the next thing I've gotta do is remove the needle, detach the needle. I'm going to take this off. I'm going to turn this pattern here into a cutting pattern, just silicon, which is fine. And then I'm going to make it long and thin. And I'm going to rotate it. Okay. So the trick here is not to cut the needle. Okay, so that needle's tungsten, so that's going to take a long time if you're going to do it that way. You want to just cut right where you have your deposition. That should go fairly quick. And all I'm going to do is I'm going to keep it at 1 nanoamp, and I'm just going to let it run. Okay, and that went pretty quick. And again, that's because I'm just cutting on the platinum and not the tungsten needle. So now I'm just going to pause here. Take a look at my electron beam. And I can see my needles kind of moving around. So I'm going to go counterclockwise on the Z, just to move it away. And now I'm going to move my needle to the park position. And I'm going to take out my platinum. And I'm also going to set it to cold because we're not going to be using it anymore. So I have to wait for my Omniprobe needle to finish moving before I can extract it. But what I'll do in the meantime is go ahead and get rid of my pattern here. Okay, it stopped. So now I'm going to take out the Omniprobe. All right, and now I'm going to bring my sample right back up to focus with the Z knob manually. And that should be close to my Eucentric. So I'm going to go ahead and I'm going to tilt up all the way to 52. And as it moves away, I can just go ahead and adjust it. And just like we did before, because we're going to get this taper as the material removes, we're going to over tilt. Ideally, we want to be plus or minus 1.5 degrees to give us an overall 3-degree difference. I'm actually going to go +2 on the front side and then just -1 on the other side for a total of 3 degrees. And the reason is I'm not really sure on the accuracy of the stage if it'll do 0.5. It says it will, but I'm not really sure it's that accurate. So I'm going to go to 50, 54. So that'll give me the front side. And I'm going to pause here. Take a snapshot there, and now I'm going to take a unpause here. So again, I'm perpendicular on the ion beam, so I'm going to double click on the ion beam, take my snapshot, and then with my electron beam, I'm going to make adjustments with the Z knob to get that to the right position. Now here's something that I prefer to do. A lot of people will start to measure their sample as they mill and everything using the measurement tool here, which is fine. You can do that. It's up to you. I mean, whatever you prefer. The thing is that takes time. All right. What I prefer to do is I prefer to go up to 15 kV here on the beam. And we're actually now going to go to analytical mode just to get a little bit more signal. Okay, F9 to adjust contrast. Okay, and I'll use my shifts to get that place. Zoom up a little more. All right, and focus. And what I'm going to use is I'm basically going to use a change in contrast in the silicon to let me know when I've gotten fairly thin. Once I get a change in contrast, and you'll see what I mean, the sample should be below 1 micron. Okay, so now let's take a look over here. What I'm going to do first is I'm going to focus and stigmate my beam, not on my sample, but right above here. And I'm going to unpause, and I'm just going to go ahead and focus and stigmate. I want to get this as sharp as possible. This makes a big difference. You want to be absolutely on the money as far as focusing and stigmation. All right, that looks good. Now the first thing I'll do is I'm going to take and kind of clean off the front section. And now the reason is you don't have to do this all the times, and certainly if you have a blanket material that is evenly coated on the surface, not a big deal. But if for some reason you've got something that may have inclusions or may have defects that you're particularly interested in, what you want to do is get a nice clean section on the front so that you can see it very clearly. All right, so we're going to polish this up. I'm only going to go to 1 micron. My application is silicon. I'm going to go all the way across the front. Now the other thing is I'm going to change my overlap to get a nice smooth kind of finish. I want to go as high overlap as I can. I'm going to set this to 95, and you notice when I change one, it changes the other. Now if I run this, it may actually give me an error. No, it didn't. Sometimes it tells me it's too many points, but that's fine. It's going to go through, and basically all it's going to do is now it's going to just polish that front surface. And all that's going to let me do is if I have a defect or if I have a discrepancy in my film, or if I'm looking at defects, I can now get a better feel for where to position my windows, where I want to do my thinning. So I'm just going to let this go. And you can see it's cleaned that up quite a bit. All right. We can clearly see here, we've got our ion beam deposition of platinum, and we've also got our electron beam deposition of platinum. So if I had some features on the surface, bumps or whatever, that would show up just as well too. I think you can even make out that there's a very thin line in here. There's actually some type of coating on the silicon. So, and we're just gonna let that finish. And the width of this is 13 microns. So I'm going to make we're going to do 2 separate windows. And I'm going to use one. I'm going to just use the rectangle tool to go ahead and thin the one side. And on the other side, I'm going to use the cleaning cross section. And like I said, you could use either one. Everyone has their own way of doing things. I've taught, hundreds of kids how to do this, and I guarantee you not all of them are doing the same way that I first taught them. So you'll kind of learn little tricks about your samples in particular. Okay, so now we've got a nice clean front section. And now I can go ahead and choose my positions wherever I want to put them. Okay, so let's come over here and let's just change this to about 5 microns. Let's take another snapshot. Again, some people would come here and start measuring, but again, it's not that big of a deal. And then the other area, I'm going to do a cleaning cross section, and that one will be 5. I just want to check this to make sure. Yeah, that'll give me. That's good. All right, so I'm going to delete that one first. So the first thing I want to do is I'm going to zoom up as much as I can. And I'm going to go ahead and place this regular rectangle here. And I don't have to go this far back. My section is only this thin. And you can see it's only going to take 25 seconds. I'm going a Z of 1 deep. And I'm just going to go ahead and I still have the same parameters I had before, 95% overlap. I'm just going to go ahead and start it up. And you can see that's the section I'm making. Bring this down a little bit. Okay, now I can actually clearly see, now I've zoomed up a little bit, I've got my electron beam deposition, and then I've also got a deposition on the surface here. You can clearly see there's a dark layer above the silicon. Okay, that's stopped. F4, if I want to, I can go ahead and take a snapshot. And now here, if I want to, I can move it in a little bit more. I can actually move it in a specified amount. So let me just move it in another 300 nanometers at a time. So that'd be minus 1.6. Okay, so I've actually moved it in. So again, at this point, I tell people just go slow. It's not gonna take you very long to finish this up. Just go slow a little bit at a time. It's only taking like 20 seconds or so each time to do this. Not a big deal. So we'll do 2 steps on that side. Okay. Right, we just milled it a little bit further. So now what I'm gonna do is I'm going to delete that one. Now I'm gonna use the cleaning cross section. I'll come over here. Same thing, we're gonna go to 5 microns wide. I'm gonna bring it right around here. Z, you can leave it at 1. You can actually probably go even to a little bit less, but we'll just leave it at 1. But again, I'm gonna try to go 95%. And just like before, I don't have to go this far back. I only need to go as far back as my sample is. Let's take a snapshot before we do this. So I'm gonna start here, same thing. It's only gonna take 43 seconds. And also, as I start, watch the graph over here, the endpoint monitor. So you can see I'm far back, my beam starts way in the back. And as I get closer, my point monitor, my endpoint monitor starts to increase. Okay, so I'm starting to now, I'm not exactly even on the sample itself, but my beam tails are starting to hit. And what that's doing, it's causing an increase in the specimen current. So now I can take a snapshot here with my electron beam. You can see I've made that little cut. Now, actually, you can see a little defect on the surface here. So that's the kind of things that you would want to look at when you first do the cleaning, or even here. If I know that that defect is something I'm interested in, I would stop here and go to the other side, but I'm not interested in it. So kind of like the other one, I can do the same thing. I can advance this by 0.3, so that would be minus 1.6 as well. And again, I don't have to go this far back. I can bring that forward a little bit. And it's only 27 seconds. Let it run. And again, watch your endpoint monitor increase as it gets closer. Okay, so now that's done. Take another snapshot here. All right, so I'm done on this side. So I've done everything with 0.1 nanoamps on this side. So whatever I've done on this side, I want to do on the opposite side. So now I'm going to go minus 1 degree. So 51. So it's going to be a total of a 3-degree tilt. I'm just going to go ahead and continue with on this side with the cleaning cross section. So I'm going to change that to top to bottom, take a snapshot, and I'm going to go ahead and position it. And again, I can go in a little bit further. I always tell students just start a little bit at a time. Each time it's taking you only a couple of seconds, minutes or so. We should have plenty of time to finish. So the one thing you want to do is you don't want to overdo it, okay? Okay. Since I kind of tilted, it's going to drift a little bit. This instrument takes a little bit of time to kind of settle out. So while I've done that, while I'm waiting for that to settle out, I'm just going to position this a little bit more so it's a little bit more center. Okay. I'm also going to take a picture down here, and we can use that to compare. Okay, so now what we're going to do is going to wait for this to get a little bit thinner, and again, a lot of people I see measuring the thickness over on the ion beam. You can do that, but you'll see that you're actually going to be able to see a change in contrast as we get thinner. So let's go ahead and take a snapshot. Everything looks good. And we're just going to start there, line it up at the top, 43 seconds. Let's let it run. And you'll see the same trend with your endpoint monitor. As that beam gets closer and closer to the platinum, to the thicker part of the area, it's going to increase. What you should notice is also opposite with the other one. So what's happening is that the beam is only coming in contact with the front end of the sample just on the end half of the pattern, right? Just as it passes half the pattern. So if I look at this pattern, if I go to the advanced area and look at the passes, it says it's going to do 30 passes. So probably around the last 15 passes is when it's actually doing its removal, and it's actually hitting the sample there. Okay, we'll take a snapshot. Now you see your contrast change. Okay, so if I were to measure over here, I would probably be on the order of 1 micron. I'm still a little bit on the thick side, so if I wanted to, I could go ahead and remove that a little bit more, but like I said, we're gonna take this really slow. We're gonna go ahead and be more cautious. So I'm gonna flip over and do the rectangle section. So I'm gonna delete this pattern here. And now I'm gonna go ahead and draw my rectangle. Same thing, we're gonna do 5 microns. I wanna go, instead of bottom to top, top to bottom. And for advanced, 95%. And then I'm gonna go ahead and line this up with the previous pattern here. And I'm gonna bring this in a little bit. So now, if I look at the passes here, 30 passes as well. But since I'm scanning the entire time, I'm going to hit that front side 30 times, okay? It's not like the other beam. So basically when I start this up, the front end is gonna be hit 30 times with this beam, as opposed to the other one where it was only hit like 15 times, kind of in the middle. And what you should be seeing is that my endpoint monitor, my specimen current is actually decreasing because I'm actually removing material. So I'm making my wall kind of very thin, and I'm not hitting it as much. It's done, it's quick. Let's take a quick. Okay, and again, I've got my transmission. So right now I know these are below about 1 micron. So now, and again, I'm gonna do this very cautiously. So now what we're gonna do, we're gonna go to 5 kV. And we can go to 4 nanoamps, we're not gonna be at 8 nanoamps. Okay, and then I'm gonna bring this back up. I'm gonna focus this and center it right there. Okay. I'm also going to take a snapshot here to compare. All right, so now I'm gonna go to my next beam. I'm not gonna shift to the front because like I said, every time I change the tilt, I'm gonna have to wait for the instrument to settle out. So I'm just gonna go ahead, I'm gonna go to, you can either do 0.5 or 0.3. Again, we're not gonna be removing a lot of material, so this is gonna be very quick. Each one is gonna be taking about a minute or so. or I'm sorry, less than a minute. So before we do that, we're going to focus and stigmate on the top here. I don't want to get too close to my sample there. Okay, we can get a nice fine focus on the stigmation here. Okay. Now I'm going to adjust the contrast a little bit just so I can get my placement really well. So now what I'm going to do with my rectangular section is I'm going to bring it in a little bit. Again, I don't have to be all this way back, 41 seconds. Same thing, let's see what we do for passes. 31 passes, not a big deal. So let's go ahead and I think I've still got this set for 1 micron depth. We could probably change that. It doesn't have to be that deep, but I'll just leave that for now. And again, we're going to look for a change in contrast. What we'll do is we'll at least do this 0.5 nanoamps on the back side 1 or 2 times, and then we'll flip to the front side. So whatever you do the back side, you want to do the front side. Okay, I'll take a snapshot over here. Okay, not seeing any transmission. I'm going to go ahead and take another snapshot here. And this is where you're seeing that it's getting very thin. This is where you're going to get a little bit more cautious. And as far as distances, 0.3 is a lot. So I'm just going to come down 0.2. So I'm going to make this 0.7 from the center. And I'm going to, again, I don't have to be this far back since this is all dark back here. I just have to be where the bright area is. And this is only going to take 31 seconds. I'm just going to go ahead and do it on this side. And then we're going to go over and do the cleaning cross section. We might change the contrast a little bit here. Okay. Okay. Subtle change, very subtle, if anything. Okay, so now I'm just going to do the cleaning cross section. Same thing as before, cleaning cross section. I'm going to come over here. I'm going to make it 5 microns, top to bottom. I actually don't have to go all the way down to 1, okay, on this one. The reason is, all my information is at this very top layer here. I really don't have to go very deep into the bottom here. So I'm just going to go ahead and change this to something like 0.6. And for my advanced, again, let's see, my passes. Well, that's a lot of passes. I still haven't set it up yet. Overlap is 95%. And I'm going to bring it, let's take a snapshot. And I'm going to bring it over here, just a little bit in. Okay, and again, I don't have to be this far back. I only have to be where it's kind of bright. And you can see that's a little bit further back. The passes, again, are only going to be 18. And we're going to look at our endpoint monitor, and you'll see that it's actually only going to be probably at the last half where we're actually going to be removing material. Okay, so I'm starting to hit. So at the very beginning, I wasn't really removing much material. I wasn't really hitting the sidewall. Now I'm hitting it. Okay, Take a snapshot here. Not much of a change. Take a snapshot over here. Kind of like before, same thing. I'm going to move this down 200. So this will be 0.9. Let's move that a little bit more. About 0.8. That's a little bit. Let's split the difference. 0.85. How's that? Okay. And again, I don't have to be that far back. I can comment a little bit more. 30 seconds. Probably again 18 passes or so. So we're going to go ahead and start. Okay, take a snapshot here. Okay, slight change in contrast. You can see it got a little bit lighter. All right, so now I've removed material from that side. I'm gonna go to the front side. So let's go back to, we're gonna make this 54. And now I'm gonna come over here and change the direction on the cleaning cross section. We'll just finish up with the cleaning cross section since we already got it set up. So we're gonna go bottom to top. Take a snapshot. Okay, and see, this gets a little bit tricky to kind of see, but you can kind of see that your membrane is kind of right there. You see how my electron beam looks? Okay, that looks good. Taking that snapshot there, and now I'm going to compare it to the one at the bottom. Okay, so that will be my comparison at the bottom here. Okay, take another snapshot. See, it drifted a little bit. That's always going to be the case. So I'm going to come up close. See if I can go up a little bit higher magnification. Okay. Okay, so now I'm going to position this right up close. Not exactly on there. Again, I don't have to go that far back. 21. Depth is still 0.6. Let's go ahead and run that. And I'm looking at my monitor here. See, it dips down because it's not really hitting the sidewall yet. And then it's going to kind of turn up a little bit. Starting to hit the sidewall. Okay, take 4. All right, wow. So I've actually removed quite a lot of material. You can see that there is quite a big difference in the contrast. Again, all of my information is up at the top here, so I really don't have to go this far below. So I'm gonna take my snapshot again, and I'm gonna move it in at this point. I still got plenty of platinum. I'm gonna move it in by 100 nanometers. So that's going to be minus 1.7, minus 0.17. Okay. And again, this back part here, I don't have to go that far back. And now what I'm going to do is I'm going to monitor that graph. I'm also going to start taking snapshots like every 3 seconds or so. So let's go ahead and start. I'm going to look at the time here, also looking at the graph, and I'm going to take a snapshot. Oops, sorry. All right, starting to hit a little bit more. I'm starting to remove a lot of my platinum. Okay, I've gotten rid of a lot of my platinum, but look how transparent my silicon is, okay? So again, one issue I'm having here on the side is you can see it looks like it's cutting off the side here. So what I'm gonna do is just preemptively just shrink that up a little bit. Let's take a snapshot, and I'm gonna make the width, let's make that 4.5, Okay, bring that in so I don't cut this off and it doesn't drop off. Okay, and again, if I want to, now I'm just going to bring it in about 50 nanometers. So I'll give me minus 0.08. Okay, and same thing again, I'm gonna run it. And almost like every second, I'm gonna be taking a snapshot. And I'm getting ready to just kind of stop it whenever I need to. Okay, I keep removing some of that platinum. But as long as I've got platinum remaining, I'm okay. Okay, and I'm starting to get really, really thin on my silicon, so I'm gonna stop because I don't want it to warp or get a hole in it. Okay, so that's gotten pretty thin. I'm gonna leave it right there. Now let's go ahead and do the other side. So on this side, let's take a snapshot. I'm gonna continue with the red rectangle. I'm gonna go ahead and set it up again. Let's do 5. The Z, we're gonna keep it at 1 like we did before. 95% overlap. And we're gonna go ahead and position that. And again, I don't have to go this far out. I can come into this really bright area. And 27 seconds, okay? So again, this is not taking very long. Same thing. It gives me a little bit more time because it's trying to remove a lot more material. So every 3 seconds or every 4 seconds or something like that, I can take a snapshot. It's trying to get thinner. You can start to see that there's a contrast change going on. I'm removing some of my platinum. But it's going very evenly across the front. And kind of like I did before, I'll come here, take a snapshot, and I'm just gonna move this in by 100 nanometers. So that's gonna be minus 0.25. And then again, I don't have to come this close. I can bring that further, 20 seconds, same thing. I'm just gonna take a snapshot every now and then. And I'm going by seconds here. So 16, like every 2-3 seconds. Notice how it's very bright at the bottom here. So it's actually thinner at the bottom than it is at the top. We may get a little bit of a hole there, but see, it's coming down fairly quick. Every 2 seconds. Okay, I'm gonna stop it right there. Okay, so you kind of see that the bottom here kind of got a little bit blown out because it's really thin down there. But that means that my samples are extremely thin at this point. They're probably on the order of 100 nanometers or less. The next thing to do is we're going to do the final polish. And we're gonna do that at 2 kV, 83 picoamps. Now what I'm gonna do here is I'm going to go ahead and uncouple my magnification, because what's gonna happen is at 2 kV, my electron beam and my ion beam are gonna be grossly misaligned. It's a huge difference. So the other thing is I'm gonna tilt to +4 degrees, so that's 56. And I'm just going to unpause. You don't have to really worry that you're removing or damaging your sample. It's really a very light kind of removal that we're going on now. I'm gonna change my contrast and brightness. And I'm gonna try and get the best possible focus and stigmation. It's not gonna be perfect. It is only 2 kV. What I'm trying to do with the 2 kV is I'm not really trying to thin anything out anymore. I'm trying to remove the damage that was caused by the 30 kV beam. Okay, so I'm gonna try and get this as good as I can get. Take a snapshot, and then let's change my parameters here. Okay, so what I want to do now is I want to position this over my entire sample just to make sure that I'm hitting my sample. And you can monitor it if you want. You can take some pictures if you want, but all I'm really going to do is just run this for at least 30 seconds, if not a little bit longer, maybe a minute. One, you're gonna monitor, make sure you don't get too thin and you don't start damaging the top of the sample that you're interested in. Make sure that you have some platinum left over. But just go ahead and start, and you can see here, and just do at least 30 seconds. We're gonna do the same silicon, 95% overlap. We want 30 seconds. You can go a little bit more if you want. You can take a snapshot to just make sure everything's okay. That's probably a little bit more than 30 seconds, but it's okay, not a big deal. Like I said, all we're doing at this point is we're removing the damage. Okay, and then we're gonna stop here, and then we're gonna go +4 on the opposite side. That's gonna be 48. And we're gonna do the same thing. We wanna make sure we're right over our samples. And same thing, we're gonna watch, and we're just gonna remove material. Again, we're just trying to remove the damage that was caused by the 30 kV beam. So it's not like we're removing a lot of material. All we're doing is removing damage. And you can see that we're well protected with our platinum. I always tell students to err on the side of caution. So if your samples are a little bit on the thick side, you still have a lot of platinum. If they're still on the thick side, you can pop them back in and thin them out a little bit more, but you can't add material to them. That's why I tell them, take a look at them, put them in the TEM. If they're too thick, just pop them in here and go a little bit thinner. Just do this polish, this 2 kV polish. And that should be enough to kind of like remove enough material and get you into the good book to make your samples just a little bit thinner. And that's about it. Started around 2:30, it's now 4:45. So with all that talking and also with the making 2 samples, you should be able to get this done probably within about when you first start with silicon, you should be able to get a sample within about 3 hours or so. Once you get used to it, you should be able to do 2 hours and less. Again, we take out a big sample only for beginners, because if you screw up, you could always go to the side next to it and then kind of finish. The last thing you want to do here to check is go to 30 kV. And one, you want to check the transparency of your sample at 30 kV. We'll go ahead and bring this down a little bit. I'm going to focus. And this might be a little bit too much to do it at. Okay. Let's take a look at the sample here. All right. So I'm going to take a nice long scan. You can see your layers. The other thing that you're seeing is you can actually see the other side of the grid through your silicon. Okay, so this You've got this thin area up here, but this that you're seeing here, that's actually your grid. You can actually see the area where we milled out when we're doing our focusing. So same thing here, you're actually seeing through your sample. So if you're actually being able to see through your sample at 30 kV, you should be okay looking at it at 200 kV or even at 100 kV in the TEM, okay? That's pretty much it. Like I said, it only took about 2.5 hours, and that's a little bit less than that, and that's with doing a lot of talking. Try it both ways. Some people prefer one over the other, so it's up to you. Right, thanks.